This is a really nice microscope. I grabbed it off of Amazon. It cost just a wee bit over $300 for a stereo microscope with a camera. And it's actually pretty decent quality. The problem with this one for me, though, is it's mostly a biological microscope. It has a light down here you can turn on. Of course, that shines lights up through the sample, and then, of course, you can see it. Really classic when you're doing biology. But not quite as helpful when you do the microscopy I'm doing for my teardown videos, which tend to be engineering related. I'm interested in microphotographs of silicon dyes and such, not like this one. And where this microscope doesn't do well is, of course, with that, because the light source is on the bottom. I basically need a top illuminated microscope. They're also known as metallurgical microscopes. Unfortunately, they're quite a bit more expensive. If I just pop up a listing for one of the cheaper metallurgical microscopes, you can see that's about $700–800. And its big difference here is here. There's basically a light source inserted between the eyepiece and the objectives. And it shines lights through some sort of very fancy prism arrangement. Now, what I don't want to do is buy another microscope, quite frankly, but I was wondering if I could modify this one. So that's exactly what this video is all about. I'm going to take advantage of the fact that I bought a stereo microscope, and I'm going to inject light down one of the viewports here to create some topside illumination. Okay, mostly a voiceover video because I used metal to fabricate the part, and that's a pretty noisy affair. I used metal because I need something thermally conductive. The LED that I'm using for the topside illumination will draw about 3 watts, so I need to conduct that heat out to the atmosphere, and of course metal is a good choice for that. My first stop was at a company called Metal Supermarkets. They will sell you little batches of metal. In particular, I got here a cylinder of metal cut out 12 inches long. It's about 1.5 inches in diameter. And I chucked it up into my little tiny hobby lathe, and I turned it down. I put a shoulder onto it so it would slide into the eyepiece. And then I put some chamfers onto it so it would be easy to handle. And I must admit, that's always satisfying work. Next thing up was to use a tailstock, and I chucked up a drill bit, and I put a hole through the center of it. And that's to pass the electric leads through to the outside. Then I took a file here, and I filed off a groove basically for the wires could pass through, because I need the LED to sit flush. And here's the final product. It was looking okay. Next stop was to get the LED attached to the metal. Thermally conductive epoxy probably would have been the best, but I just had a little tube of inexpensive regular epoxy. Not a super thermally demanding application though, so I just attached the LED to the metal using it, resulting in this arrangement here, which is almost complete. The next thing I needed though, however, was to create a diffuser. When I put this in without the diffuser, I'll just put up a picture. You can see essentially the LEDs were too hot, too bright. They're illuminating the center part really well, but creating really deep shadows. To do that, I went off and cut some circular discs out of some white plexiglass. You can see on a chuck there I taped on to a oak holder some plexi. I don't have a proper faceplate that you would normally use for lathe, but it worked okay. And then my next thing I had to do, of course, was to take that plexiglass discs and create a much larger assembly, much thicker assembly. And the way I did that was to weld them together, and I truly did use welding. Plexiglass can be affected by acetone, basically dissolves, and you can take advantage of that. So I essentially painted acetone onto the disc and then stacked them up. And that was important because I wanted a void-free finish which was optically clear, and this works really well. It's a really solid technique. So eventually that dried up here, and essentially I have the assembly. So just before I slide it into the eyepiece, you can see they're 2 separate pieces. What I need to do is attach them together. I decided just to tape them. I turned down the shoulder in the eyepiece just slightly. It's too small. Basically the thickness of some metal tape, and that should give me a nice firm fit. So I'll rotate that around the cylinder here, and then put it into the eyepiece. Okay, so here's the final setup. Binocular microscope. One eyepiece has a digital camera into it. The other one, of course, this new topside illuminator that I just created. On the slide there I have an integrated circuit. And this is the view of the camera application, which will display, of course, the dye. It's black right now because, of course, there's no light. But now if I turn on the power supply, you can see that the camera can now see the dye. And let me just zoom into that. And of course, here's a lovely picture of the dye and all of its details. And of course, this is what I was wanting to do, basically to illuminate opaque samples. So looks like I have a reasonable solution for topside illumination, and I have a poor man's metallurgical microscope.